So on this Cartesian plane, what's the first thing I should do always? Label, yes. Look at the answers I get when it's not freaking online. I just recorded that. That's fine. They can listen to my happiness as well. 90, 180, 270, 360. Okay. Now this is quadrant 1, 2, 3, 4. Where does 238 fall? In which quadrant? That is not a 4. In quadrant 3. I thought someone said 6, and I was a little afraid because there are 4. Okay. 238 is how much more than 180? If we go 238 minus 180, what do we get? 58. So we're 58 more. Remember 45 is kind of in the middle. And then 60 splits and 30 splits, so it's a little less than a 60. I'm not going to like pull out a protractor and be like, dude, you're off by a few degrees. Like, I'm not going to do that. However, if you like draw it here and it's supposed to be 58, yeah, that's off. Okay? You need an initial, you need a terminal, and you need an angle. And then you'd label as 238. Now, when we're in quadrant 3, how do we get the reference angle? Anyone remember? Yeah, you just minus 180 from it. Whenever you're in quadrant 3, you always minus 180. So to get, oh no, oh, it is. Okay. Reference angle, we're going to go 238 minus 180. Shockingly, we did it down here to actually draw it anyway. So it's 58 degrees. So that question would technically have 2 marks, one for reference angle and one for the actual drawn angle. Now this one, given the trig ratio sine theta equals -4/7 and it's between 270 and 360, they want the other two primary trig ratios. That means I need x, y, and r in order to do my trig ratios, correct? So the first thing I have to do is draw it, and I gave you this in hopes that you'd know that. 270 to 360. Don't forget your degree symbol because next year it'll be a problem because there's radians. So it falls in here. Now you need to do the reference triangle, right? It's right here. Now sine is y over r. Now remember I told you I'll give you those formulas on the formula sheet, sine, cos, and tan with y's and x's and r's. So you'll get those, don't worry about that. So it's y over r. And my r has to be positive. So I told you this on the meet, but I'm going to show it to you again anyways to prove a point. If it was written like this is y and this is r, we agree? But my r can't be negative. So I would have to move the negative up here and turn that to a positive. So I can put the negative with the r, but you have to catch that it can't be negative and move it up. All right? So my y is equal to -4. My r is equal to 7. And now my x is equal to positive something because it's in quadrant 4. Every x is positive there. Now how do I find the x? Do we remember? Pythagorean theorem, but flipped around. Yeah. Yeah, so we're going to get x squared equals r squared minus y squared. Let's take a height. So we're going to get x squared equals 7 squared minus -4 squared. X squared equals 49 minus 16. So x squared equals 33. And then I take the square root of it and I get plus or minus, but because I drew the triangle, I'm going to get square root 33, and it's positive. And I can't reduce 33. If I could reduce 33, say it was like 24 and I could do 4 and 6, then I would reduce the radical, right? But 33 can't be reduced, so we just leave it as root 33. Then we have to do our other two trig ratios. So let's do cos theta equals x over r, and tan theta equals y over x. And remember I told you those formulas would be given to you, right? So there's no way, if you mess them up and write them wrong, you just copied it off the formula sheet wrong, right? There's no memorizing this year. Next year you'll have to have them memorized. So cos theta equals x is root 33 over r, which is 7. Done. This question would be out of 3 marks. This would get you 0.5, 0.5, drawing it. This would get you 1 mark. And then doing the other tan would get you the other mark. So tan theta equals y, which is -4 over root 33. But then I have to remember to rationalize the denominator. I can't do this. So I'm going to go tan theta equals -4 over root 33. And then I have to multiply by root 33. Remember, you can't have a radical. So we did that unit first. So we're going to get -4 root 33 over 33. And we can say tan theta. And that would get you the other mark, so it would be out of 3. Does that make sense? Remember it? The hardest part of these questions is reading it and knowing what the heck you need to do, right? So in this case, if I give you a trig ratio and I ask you for the other trig ratios, you need to draw a triangle and find the third side immediately, okay? When you're given a trig ratio, ask for the other trig ratios, draw your triangle, find your third side. Then here's the same looking question, totally different. So I put these side by side so you can compare them, so that you can see the difference in how it can be asked. So it says, given the trig ratio tan 3/4, determine the reference angle. Do I want a trig ratio? Do I want the other trig ratios? Do I need to draw the triangle and find the third side? No, some people will ask me, well, which quadrant is it in? It doesn't matter. I just want the reference angle. So when I find reference angles, to get the reference angle, remember I have to go tan theta equals 3/4. Now remember, if it was -3/4, I would still put +3/4, right? With the reference angle, we use the positive, always. We agree? So that's going to be the thing you have to remember. When you use the reference angle, we use the positive. Then we're going to tan -1 to get the theta away, or to get the tan away from the theta, sorry. So then we just go theta equals tan -1 of 3/4. So type that into your calculator in what mode? Degree. So you guys will be able to always have yours in degree mode till next year. Then it flip-flops between radians and degrees, so enjoy it for this year. So we get 37 degrees. If you take 30-1, you flip-flop between radians and degrees. So that's the reference angle. Okay? What if I give you this? Say I give you sine theta equals -1/2. And I want the reference angle. You try that one. Sine theta, sine theta equals -1/2. Try that one. I want the reference angle. To do the reference angle, are we allowed to use the negative? No. So to get to the reference angle, the very first thing we're going to do is go sine -1, or sine theta equals 1/2. -1/2 makes a difference later when we go to actually find the angles, but right now we're just doing reference angle. And then we're going to do sine -1. And so we get theta equals sine -1 of 1/2. Which is what degree? 30. So whenever you're finding a reference angle, you need to take the positive. If you're someone who did not do that, or you know you're probably not going to do that, I would leave myself a little note. Say, when I find the reference angle, I always have to take the positive fraction, right? Leave yourself a little note, highlight that baby, so when you go back, you see it. The next one It says, given the coordinate -4, 6, determine the primary trig ratios. So the first thing we're going to have to do is draw it. Now, if I don't show the Cartesian plane, you have to know to draw it. So when I put the Cartesian plane, it's there for you to remember. Just so you guys know I'm recording, so everything you're saying, it's here. All right. 1, 2, 3, 4. And now it's still listening to you, David. Uh-huh. Yeah. Mm-hmm. Sure. Sure. Microphone's crazy good. Okay. -4 to the 6. And -4 and 6. And then we draw our reference triangle. So it's always the bow tie triangle. The one towards the x-axis. Now we know x and we know y. So x equals -4. Y equals 6. We need to find r. So r squared equals x squared plus y squared. R squared equals 6 squared plus -4 squared. R squared equals 36 plus 16. So r squared equals 52. Square root that baby. And you get plus or minus. But r always, because it's a radius and it's length of measure, always has to be positive. 52, can I break it down into anything? I think I can. I think it's 4 and something. 4 and 13? Yeah. When you take the 4 out, it becomes 2 root 13. If you're someone who's struggling, remember there's lunch hours, right? Come in, ask questions, more school. Another time. Can't, you need after school, you can message me. Figure that out too. So sine theta is y over r. So in this case, sine theta is y, which is 6 over 2 root 13. The 6 and the 2 can cross off. We get 2 out of both of those. So we get 6 divided by 2 is 3. 2 divided by 2 is 1. So I have 3 over 1 root 13. Am I allowed to have a root 13 in the denominator? No. Just have to multiply by it. So sine theta equals 3 root 13 over 13. And we have to do cos theta, just x over r. So cos theta equals x, which is -4 over 2 root 13. Take a 2 out, you get -2. Take a 2 out, you get 1. And then we have to rationalize it. So we get -2 root 13 over 13. And all we have left is tan. I should write this as close to the Tan is nice because tan is y over x. And y over x in this case is just numbers. There's no radicals, right? So when you're given a coordinate, tan is the easiest one to get. Tan theta, because you're already given the y and the x. Tan theta is y over x. So tan theta is 6 over -4. So tan theta equals -3 over 2. And you can take a 2 out of both. Number 5. Unit circle handy. Off the unit circle goes Calgary Stampede. Remember? Calgary Stampede. There's a girl in my class named Crystal Schneider. I just put her, she's going to be on YouTube now. I just said her name. Didn't ask her though, so maybe I should. Anyways, Calgary Stampede. So it's cos theta, sine theta. So off of the unit circle, remember that the answer for x is where your cos answer is. Your answer for y is your sine answer, correct? And then tan, we actually have to do y divided by x. Godspeed, sister. Godspeed. Okay, So tan, we have to do y divided by x, correct? So tan I can't just pull off the unit circle, but the other two I can. We agree? So I go to sine of 30. So go to 30 on your unit circle. And tell me what the y value is. And everyone should get 1/2. We go to 30. And we pick the y value, right? And it's 1/2. Does everyone understand that? Yeah? Then cos 240. So we go to 240, which is in quadrant 3. Go look for 240. And now we're going to look for this is the y value. This is the x value. So at 240, what's my x? Negative 1/2, I hope.
Yeah.
Okay, everyone got negative 1/2? Then tan of 120 is a little harder. What we have to do is we actually have to do, at 120, we have to do y divided by x. So what, at 120, what is my y? I believe it's √3/2. Divided by what's my x? Negative 1/2. What did I tell you about stacking? What should you immediately do once you start stacking fractions? Yeah, write them horizontally. Because we're going to have a division symbol between them, and then we're going to flip and multiply, right? We learned that in rationals. So whenever we have stacked fractions, that's awful looking. We're going to write them side by side. So we're going to go √3/2 divided by negative 1/2, which is actually equal to √3/2 times 2/-1. And so we multiply across the top, we get 2√3 over 2 times -1, which is -2. What can I do then? You got 2? So I'm going to get √3/-1. And I told you that's not wrong, but that multiple choice answer won't be there. Yeah. So the negative, if it's just a -1 on the bottom, you can actually bring it up. Negative √3. So technically tan 120 equals negative √3. Remember all that? Fun times. Now you weren't the most, like, the greatest online student there ever was. You're way better in class. You're like my daughter in grade 4. I told her if she ever asks me to do online, the answer will immediately be no, so don't even ask. Because we had so much homework to do. We did, her and I. I didn't want to do her homework, but we were working together on it for lots of hours. Because she said, and she's a good student in class, like really good, like you. And she said that when she clicked on the actual Google link in the Google Classroom, she didn't realize off to the side there was an assignment that you could click on to do the assignment. That's what she said. Yeah? Except they were starting to be filled in, so that excuse didn't really work because she actually had worked on it. I was like, next time don't leave actual evidence that you opened it. We're going to learn from these mistakes, when we want to play that game. We leave that blank, right? Then she went, oh, I only thought there was one page. I was like, yeah, sure. Well thought out. That was some quick thinking, right? Yeah. We need to go take pictures of plants. Leafy plants, and so deciduous and coniferous, and then ones with smooth stems, and ones with rough stems, and plants, and weeds. We pull a weed out and then describe the root of the weed. That's what we had to do. We didn't want to do that. We just wanted her to, but we did it too. Fun bonding time. Mom-daughter time. That is not a good idea. That's how you get kicked out of university. Yeah. Because there's copy, and even here, they have copy-paste programs where it tells how much you plagiarized, hey? You know that, right?
Yeah.
Yeah, there's an app that tells you what percentage of your paper is plagiarized. Yeah. It doesn't work. It'll still tell how much is plagiarized if you shift F7 and change a word. It'll tell how much you're not. That's not sneaky. And I love the plagiarizing when you don't change the font. So you copy paste and it's in like Times New Roman, italicized, and then you copy paste from a different place and it is a different font, not italicized. No, it'll tell how much plagiarism there is.
How does it tell, like, when you write it by accident?
You won't write it by accident.
I mean, I could.
But you're not going to.
You know the
Okay. We're here. We're not. We're here. Okay. So we did the exact trig ratios of this, right? We can pull these off for unit circles, correct? So go. Sine 30 is what? What did we say? It was 1/2. And cos of 240 was what? Negative 1/2. Now I want you to do tan 315 and tan 90. Go. Try. Tan 315, tan 90. Tan 315, tan 90. I'm going to give you one hint to tan 315. It works out to a nice number once you divide the ugly numbers. Thanks for checking in, Bowden. His filing system is failing right now. Yeah. His filing system is a debacle. So tan 315, we have to do y divided by x. And at 315, my y is negative root 2 over 2. And my x is root 2 over 2. When I write them sideways, I get negative root 2 over 2 divided by root 2 over 2. What happens when you divide two numbers that are the exact same together? You get 1. Now this one happens to be a negative divided by a positive version, so you actually get negative 1. So at every 45-degree reference angle for tan, you're going to get a positive 1 or a negative 1, just so you know. So that's why I know at 315 or 225 or 135 or 45, all of those will end up being positive 1s or negative 1s. Because at 45, look at 45. At 45, you have root 2 over 2 and root 2 over 2, right? So you're going to divide them, you're going to get a 1. At 135, you're going to have root 2 over 2 divided by negative root 2 over 2. So you're going to get a negative 1. At 225, you're going to have negative root 2 over 2 divided by negative root 2 over 2. Which is going to get you positive 1, and then this one gets you a negative 1. So at those 45s, you're going to get 1s or negative 1s. Those are the nice ones. So if I give you tans at 45s, you'll be like, yeah, those are awesome. Tan at 90. Move on. Okay, so I have to do y divided by x. What's y at 90? Rhymes with fun. It's a 1. And then an x is 0. What happens when we divide by 0? We got problems. That's what happens. Yes, undefined. Boom. Box that. Move on. Be proud of yourself. You rocked it. Okay. Flipping over to something new. Yay, I know. So, which points lie on the unit circle? This is what you need to know. This is going to come up in grade 12 as well. I'm going to highlight this, and every time I see this, I think this. So I'm going to go highlight. On the unit circle. When I read on the unit circle, I immediately highlight it, because if it's telling me it's on the unit circle, it follows the equation x squared plus y squared equals 1. Now I'll explain why. what is the radius on your unit circle? What is the radius on the unit circle? Do you remember? It's 1. Because it gives us 1, 0, 0, 1, negative 1, 0, 0, negative 1, right? It has a radius of 1. And remember, what's our Pythagorean theorem formula? X squared plus y squared equals r squared. And what's r on a unit circle? 1. What's 1 squared? 1. So instead of writing it each time, we could go x squared plus y squared equals r squared, right? But that is just this. Because 1 squared is 1. So if it says that what point lies on the unit circle, you're literally going to use the formula x squared plus y squared equals 1 whenever you read on the unit circle. Okay? And we're just going to plug them in and see if we get 1. See if left side equals right side. So I'm going to go x and y. And I'm going to plug it into that equation. I'm going to go negative 5 over 13 squared plus my y, 12 over 13 squared in brackets. And I'm going to see if it equals 1. How do I know? They're like, it's fractions. No, not today. It's fine. Type that baby in your calculator. See if you get a 1. Type the left side into your calculator. Everyone type it in. You should get 1. If you're not getting 1, you are not typing it in right. Make sure you're using brackets, David. Yeah, the negative has to be inside the bracket. Oh. So when you type it in, you should get a 1, because it's going to get you 25 over 169 plus 144 over 169, which is 169 over 169, which is 1. So we get 1 equals 1. So we'd say yes. Which point lies on the unit circle? Yes. That doesn't make any sense. This one? I'll just circle it. Oh. Yes, that's like answering totally wrong. We'll box that one and give it a check mark. That one does. Okay, you guys are going to try the other two. Try them out. Try the other two, please. So this one we're going to go 5 over 6 squared plus 1/2 squared equals 1. What does this side equal? 5, 6 plus 1/2. 5, 6 squared plus 1/2 squared. You type it in? Did you get a fraction? Okay, what do you have to do with fraction? Or else it's terminating. Or it's not terminating. So it's 17 over 18. So 17 over 18 does not equal 1. So it's close. It's 0.944 of a radius, right? It's giving a radius of 0.944, so it's close to the unit circle, but it's just kind of floating on the inside of it. So this one is not. Then this one we do negative 2/3 squared plus negative root 5 over 3 squared equals 1. And this is going to get you 4 over 9, 5 over 9, which is 9 over 9, which is 1. Matches? So that's if I just ask you, is a point on the unit circle? Okay? So when I ask, is a point on the unit circle, you do that. Now this one says, each of the following points lies on the unit circle. Once again, we have lies on the unit circle. In grade 12, I make my grade 12s do this too. I highlight it, and I immediately go and say, okay, then I can use the equation x squared plus y squared equals 1. If a coordinate lies on the unit circle, then it can fit into that formula, right? Now, whenever you're solving with an equation, even from right away from Science 10, in physics unit, when you solve there and you have to get a variable by itself, you can only be missing one variable, correct? If you're missing more than one variable, you can't solve. Then you're kind of just stuck. So here, I'm missing a y, correct? So when I go to fill it into that formula, the only thing I can be missing is a y, which makes sense because my r is just 1 squared, which is 1, right? So it should work. So if I'm missing the y, I could write it as x squared plus y squared equals 1, or how else could I write it? I could rearrange this, couldn't I? Keep the y by itself by subtracting it. So instead, for this formula, I could use y squared and subtract the x squared over. So 1 minus x squared. I could fill it into that form because it's the exact same as the above, just isolated for y. Does that make sense? You guys see what I did? Looking for head shakes, yeah? All right. So we're going to go y squared equals 1 minus negative 2 over 3 squared. So type this in and get a fraction. Y squared equals. Type it in and get a fraction. We don't want decimals here. I don't know why I put it in. Okay, so we're going to get 4 over 9. So we get 5 over 9 should be what you get. Because it'll be 9 over 9 minus 4 over 9. So you get 5 over 9. Now, we're going to take the square root of both sides. When we take the square root, we get what in front of the square root symbol? Plus or minus. Now, in grade 10, you were taught this. You were taught that if one of the numbers in the fraction is a perfect square, you're going to want to split the radical up. You were taught this in grade 10. So instead of writing this as root 5 over 9, I can write it as root 5 over root 9. And the reason why I would want to do that is root 9 is 3. It gets rid of the radical being in the denominator problem. So if, when you have a full radical over top of a fraction, if one of these two numbers is a perfect square, which 9 is, you can split the fraction up into separate radicals. So we can go y equals plus or minus root 5 over root 9. And we only split them up when one of them is a perfect square. Now the root 5 is going to stay root 5, so plus or minus root 5. But the square root of 9 is 3. And we've gotten rid of our rationalizing denominator problem, correct? The big problem here, though, is we have two answers. We have a plus or minus. So I gave you what quadrant it's in to narrow it down. So it's in quadrant 3. So this is 1, 2, 3, 4. So it's down here. So I have two answers for y, but I really only have one that works. Yeah, it's going to be a negative. Bowden has brought his hand signals to class now. So it's going to be a negative because what are y's in quadrant 3? Negative, right? If I said quadrant 4, it would be negative, right? If I had said quadrant 2 or quadrant 1, my answer would be positive root 5 over 3. Does that make sense? So because it's in quadrant 3, it's going to be equal to negative root 5 divided by 3. There's my answer. We're going to try the second one. So for this one, if I want to rearrange that formula, I'm going to get x squared equals 1 minus y squared this time because I'm looking for x. So I'm going to get x squared equals 1 minus 4 over 5 squared. So x squared equals, it's going to be 25 minus 9 over 25. Yeah? Should be 25 minus 16. Yeah? 9 over 25. Everyone have that? And then what do we have to do? Square root. And we square root, we have to make sure we take that. Positive and negative. This one actually works out nicely, both of them. So we're going to get plus or minus. The square root of 9 is 3. The square root of 25 is 5. It actually works out nice. Because both of them are perfect squares. But we need to be in quadrant 2. 1, 2, 3, 4. In quadrant 2, are my x's positive or negative? Negative. See, he's picked up on your hands. X equals negative 3 over 5. So we need the quadrant to narrow down if it's plus or minus, right? Okay. Another thing we could ask you. So I can give you the point xy is located on the terminal arm of angle theta, and the unit circle intersect. Determine the coordinate of the point for the given angle. So I want the coordinate at 135. Go. Literally, if you have your unit circle in front of your face, you just write down what the coordinate is. So you're going to do 135 and 210. Oh, they're still easy. Both of them are on the unit circle. So for 135, you should get negative root 2 over 2 and root 2 over 2. And you go to 210, which is in quadrant 3. And you should get negative root 3 over 2 and negative a half. Childhood memories are gone because I have the unit circle stuck in my head. It's bumped out, I maxed out, and replaced childhood memories with unit circle. Just sad, right? No joy there. Just kidding. I just lost childhood memories because I'm old. That's it. All right. Identify a measure for theta in the interval 0 to 360. So that first one I gave you was an angle and I wanted the coordinate, correct? Now I'm giving you a coordinate and I want the angle. So you're working backwards. So we can narrow this down. This is negative and negative. What quadrant are my x and my y negative in? 3. So I go look in quadrant 3 and go look for that. Remember, if they're the same, it's the 45-degree one, right? So go look, figure out the angle that works for that. So it's going to be 225. Theta equals. Now, that second one is also a negative and a negative. So it's going to be in quadrant 3. So what's negative a half and then negative root 3 over 2? Theta equals, shouldn't be 210. You have them flip-flopped. It should be 240. Because negative a half and negative root 3 over 2 should be at the 60-degree reference angles. The last thing I can give you is this, and you're not going to use your calculator. You can verify with your calculator in the end, that's fine. But I want, it says here, determine the following exact solutions. And in this unit, when it says exact solutions, that often leads you to say, go to your unit circle. And get values. So it says exact values. You can find exact values on the whole outside of your unit circle. So sine at 315. What is 315? Go find it. And sine, is it x or y? It's y, because it's Calgary Stampede. So we're looking for the y at 315, which is negative root 2 over 2 plus cos of 150. That's the x at 150. What do you get there? Negative a half. Negative a half? Now this one is nice because it actually has common denominators. That's why I did this one after rationals, because if it doesn't have common denominators, you're going to have to make it. So they both have common denominators of 2, correct? So when you add, you need common denominators, so this is going to be all over 2. And then people try and make it way more, less complex, yeah?
Why is it negative 1?
The x at 150?
Oh, and I thought you didn't lie.
No, yeah, x. You're not going to say it. Negative root 2 minus 1. Can I make that any prettier? Nope. That's it. We box it. That's exact values. The moment you turn it into a decimal, it is not exact. Remember how I said that? Exact values are not decimals. If you turn it into a decimal, it is not an exact value. So if you type these into your calculator, you're going to be in trouble. So tan 225. Well, I know tan takes a lot more work than cosine sines, correct? So I'm going to go do tan 225 down here. Tan 225, which is y over x, correct? What's my y at 225? Negative root 2 over 2. And I'm going to divide it by negative root 2 over 2. Because it's two fractions, I'm just going to write them side by side. What happens when I get that negative root 2 over 2 divided by negative root 2 over 2? You get a negative divided by negative, you get a positive 1. Yeah, that was kind, hey? So we get 1 minus sine at 135, which is the y at 135. What's the y at 135? Root 2 over 2. Now I need to put these together. I can't put them together unless they have common denominators. This one is 1 over 1. So what could I multiply it by? 2. So we're going to get 2 over 2 minus root 2 over 2. And we can write it all over 2. And on the top we just get 2 minus root 2. As good as it gets.
Could you like reduce the two twos in front and no because then negative?
You can't because this has a 1 in front of it. So the number has to come out of here and this coefficient and this one. Good question. So it has to come out of every single term and it can't come out of this one, so we have to leave it. So your homework is going to be to do C, D, E, and F, and I'm reducing the other parts of the homework too. 1 second. That's my 20 dash at home. 1 second. Someone have their textbook with them? Christian, do you have your textbook?
Yeah.
I just borrowed it. I left mine under my desk. So for homework, you have to finish C, D, E, and F. I would put it on a separate sheet of paper because that's not enough room. C, D, E, and F. And then I want you to do so number 12 and 13. So you're doing this, 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 and this. You're doing number 12 and 13, and you're also determine the value of x on the unit circle that. So it's literally C, D, E, F, page 96, 12, and 13, and this. We're going to go through C, D, E, and F tomorrow, and this question tomorrow. You have 16 minutes. If you work, I bet you can finish your homework. These ones maybe not, because they're a little bit more work, but you need to get common denominators quick. Try them out.